Hi everyone, welcome back to my training series entitled Understanding EMV. This is the 8th video in the series, and in this video we will start with the section called EMV Parameters within the EMV Issuing section. Just a point to note, this is quite a large section. There's about 65 slides in my presentation. So I think in order for us to effectively get through the content, I'm probably going to break this section up into 3 separate videos. So videos 8 being this one, videos 9 and videos 10 will start, continue, and complete this section on EMV parameters. Okay, so let's get straight into EMV parameters in the EMV world. All right, so this section will look at some of the data elements that we personalize on an EMV card. Okay, so these are the tags that live on the chip card itself. And there's many different tags or data elements that we personalize on the card, and some of them are used specifically during a transaction, and these enforce the transaction rules and the product rules of the card. Some of these tags are passed from the card to the terminal, and some of these tags are not used in the transaction directly, but they do reside in the card, and they act as enablers for the other tags to work. Just to point out that the section on EMV parameters is not comprehensive, so I'm covering a subsection of these EMV tags. I've basically tried to focus on the tags that I thought are most pertinent, most relevant, and will add most value to your understanding of EMV. But obviously there's quite a bit that I haven't added, and if your role or your job is to personalize or configure the applications on these chip cards, then obviously you would have to actually get a full list of all the tags by reading through the technical specification from the card schemes that will define all of the tag requirements for the application. All right, let's get straight into it. So the first tag I'm going to talk about is something called a PSE, right? It's a payment system environment. This tag has no hex tag, but basically a PSE is a list or directory that we store on the card, right? And its primary purpose is to identify all of the applications that may reside on this card. So let's take an example. We've got a single physical card, a single piece of plastic. So looking back at our issue, the hardware and software sections around issuing that we covered in previous videos, think of you've got a single physical card, a single physical piece of plastic, single chip, single contact plate. But then within the chip, we say that we load software applications, right? And each application sort of acts as a virtual card in its own right. So a PSE is really useful when you have, say, multiple virtual cards that reside on one piece of plastic, and we use a PSE to list these separate applications. Okay. And if we do personalize the PSE onto a card, what it actually does is to allow for a terminal to select the relevant application faster. Okay, it saves time. So important to note that we say some cards are set up with PSE. So what this means is that a PSE is not mandatory. If you look at the market today, you'll find lots of cards out in the market that aren't personalized with a PSE. Okay, but if they do contain a PSE, then just note that during a transaction, if the PSE is supported by a terminal as well, then in the transaction, a terminal will use implicit AID selection. Okay. If you have a card that is not personalized with a PSE, then during a transaction, we use a process called explicit AID selection. Now, you're probably wondering, what is implicit AID selection, explicit AID selection, and maybe even what's an AID, right? So don't stress too much about it. When we go into the acquiring section in one of my later videos, we will discuss the differences between explicit and implicit AID selection as we actually, walk through the step-by-step transaction flow and how the applications are selected. In terms of what is an AID, just hold on to your seats. We are about to discuss this in the next slide. Okay, so AID. AID stands for Application Identifier, okay, or AID for short, and it's personalized on the card with a hex tag of 4F. Okay, so as we mentioned before, okay, the actual payment mechanism that lives on the chip card are referred to as applications. Okay, and so just remember, think of an application is equivalent of a virtual card. You could have one physical piece of plastic, but you could have multiple virtual cards that live on it, and each virtual card is also called an application. Right? So the application types are defined by the card schemes, by the card associations. So when we talk of applications in the EMV world, we expect to see applications like MasterCard Credit or MasterCard Debit, Visa Credit, Visa Debit, Visa Electron, Maestro, etc. The applications are standardized, right? So Visa issues their application standard, MasterCard issues their application standard, and issuers have to either use these applications from the card schemes, or if they develop their own applications, they have to build it according to the exact specifications of the card schemes. And the purpose of this is to ensure that if this card is used globally, if it's used anywhere in the world on terminals that accept the scheme, the MasterCard or Visa, the terminal accepts a transactions on any MasterCard or Visa uh, payment application, then these cards have to be globally interoperable, right? They have to work without any issues, regardless of where in the world you are, and that's what the MasterCard and Visa brand does, right? So they ensure that a customer would, for example, a customer with a Visa card, no matter where he travels in the world, as long as he's using a device that is sort of branded or certified by Visa, that card will be accepted there without any issues. Okay, so it's very important that these standards are adhered to. So, during a transaction, we use AIDs, or application identifiers, to allow the terminal to very quickly identify, what sort of applications it is about to interact with. Okay, so an AID is made up of sub-elements, right? So the excuse me. An AID is made up of two mandatory or two compulsory components. It's made up of something called a RID and something called a PIX. So a RID plus a PIX gives you a standard AID. So let's talk about the first component, which is called the RID, which is Registered Application Provider Identifier. The RID is an alphanumeric, fixed length, unique identifier allocated to each card scheme to identify EMV applications provided by the scheme. Okay. In a nutshell, when constructing the AID, the RID is mandatory, and the purpose of the RID is to identify under which scheme standard does this application fall under, right? The second part of the AID is something called a PIX, okay, Proprietary Application Identifier Extension. The PIX is a variable length numeric identifier allocated by card schemes to differentiate between different applications, example, credit and debit applications provided by that scheme. The value of any PIX is proprietary for each scheme and is appended to the RID to create the AID of each application. Okay, so what we're trying to say here, in a nutshell, firstly, when constructing the AID, the PIX is compulsory, it's mandatory, right? Unlike the RID, which identifies a scheme, the PIX identifies the product, right? So RID says, is it MasterCard, is it Visa, and the PIX says, is it debit, is it credit, is it prepaid, is it electron, etc. There is a third component that could be appended to the AID, okay, and this is called a PIX extension. Now, a PIX extension is an alphanumeric suffix that we append to an AID to differentiate between similar AIDs on the same card. Note that the PIX extension is optional or conditional, and we only use it on cards that have multiple applications. Right? Remember what we've been talking about? We've got a single physical piece of plastic, but we've got multiple applications and multiple virtual cards on there. And in the case where we've got multiple applications where the AID looks the same, then we use a PIX extension to differentiate between the two. Okay, so I think let's sort of graphically illustrate firstly what an AID looks like, and then thereafter we'll proceed into going into the PIX extension in more detail to explain that. Right, so let's talk about AIDs first. On this table, you'll see that I've got a column here that refers to the root, right? Remember we said the AID is equal to or is made up of the root plus the PIX. Now, this is not a complete table. There are sort of more rows available, more schemes available. I just took a sample subset to, just to illustrate as part of this training. So you'll see that the first root in the first row is A, is 8 zeros and a 3. Okay, and you see that the first two rows have the same thing. Now, if you look to the left, you'll see that all three belong to Visa. So what this tells us is that if you ever see an AID where the root component is A803, it means that the application we are dealing with belongs to Visa. Okay, and the same principle applies to an application where the root is A804. As you'll see, all three of them all reflect MasterCard. American Express is A7025 and Discover is A60152. Like I said, there are others. There's JCB. There's a couple of other schemes that I haven't listed here. Okay, so that's the root. Let's talk about PIX. Okay, remember we said root identifies the scheme, PIX identifies the product type. So if you look at the PIX, I've got 1010. So let's look at this line. So this refers to a Visa credit debit. So what we're saying is that if you see an AID with A8031010, we are referring to a Visa credit or a Visa debit application. Okay, so when you talk of AIDs, this is the structure of your AIDs. This is what the template or format of which you will work with when it comes to AIDs, right? So Visa Electron has a PIX of 2010. So I mean, to derive the AID, all you do is you add the root and the PIX, and that gives you a 8032010. And the same sort of concept applies as you move down the rows. Okay. Let's talk a bit now about PIX extensions. All right. So let's slow it down a little bit and let's delve into the example that we've been referring to since the start of this video. We've got a single piece of plastic, a single physical card, right? Within the card, right, on the chip under this contact plate, let's assume that in our particular scenario, we've got two applications. Okay, so what does two applications means? It means I've got two software payment mechanisms or two virtual cards. The first virtual card or application is a MasterCard credit application. Okay, and the AID for this is A8041010. The second application that lives on the same card is a MasterCard debit application. Okay, and the AID for MasterCard debit is A8041010. Do you spot the problem here? Okay, so even though we've got two different product types, the AIDs look exactly the same. So this now starts to get confusing for the terminal. It starts to get confusing for the people having to use a terminal. And so in order to prevent this confusion and to overcome this, what we do is we use PIX extensions to further differentiate between these two AIDs. Okay, so we add a PIX extension of 1101027001 to the credit application, or the credit AID. And to the MasterCard debit AID, we add a 1101027002. So now you can see that unlike this comparison where there is no unique value, in this case we do, right? So the first one ends with a 1 and the second one ends with a 2. Now, this is not a random construct, right? This is something that there's a defined format that we are expected to use, and so all terminals in the world will sort of look for this format to be able to either identify or differentiate. So the PIX extension format is in the format of DCCCXX, where D is actually the hex value of D. So we know that D is hex, but we translate into binary. So hex D equals 1101. Okay, so there's your 1101, right? Then I've got CCC. CCC stands for country code. Okay, so in this case, you'll see we've got 027. And this then means that we are dealing with South Africa. Okay, now obviously if it's a different country, then you will apply the relevant country code there. XX is a value defined by the National Registration Authority, right? So in this case, we have a payment association of South Africa that sort of regulates the interaction in the payments in the card and payments world across all the banks within South Africa. And so we would need to go to the Payments Association and sort of collaborate with all the other banks in the country and say, okay, so we are registering for our card this PIX extension for our MasterCard credit and this PIX extension for our MasterCard debit. And obviously if another bank came in, they could use a different value to differentiate from us. Okay. So I hope that's given some light in terms of how PIX extensions work and how they are used. So I think we're ready to move on to the next one, which is application label. Okay. So let's talk about application labels, right? So for every AID that we store on the card, we have to have an associated application label, right? And the reason for that is simply this: during a transaction, the terminal will find all of the applications on the card that it can transact with, right? And it will present them on a screen and offer it to the cardholder to say, Bob, I'm the terminal. I found 2 applications available in the card for transacting. Which one would you like to use? Now, if the terminal presented this string of letters and numbers to Bob, Bob's going to be completely confused, right? So what we do is we use something called an application label that allows us to, sort of in human language, associate a name or a label to this AID. Okay, so for AID A8041010, the label is MasterCard. Okay, application label is specified by each card scheme for each of the products. Okay. We have to write this to a card, so it's a mandatory field across all the schemes. Okay. So, remember in the previous slide, using our example, we said on our card we've got 2 separate applications. One's a MasterCard credit and one's a MasterCard debit. And we know we've made each AID unique. So one ends with a 01, one ends with a 2. But the problem now comes up is that if you look at the application label, because we assign the label just to the AID, we ignore the PIX extension. In both cases, we have MasterCard. Now, once again, this gets very confusing, especially for the human being having to select which of the applications he'd like to transact with. So Bob, wanting to buy a pair of socks at the shop, sticks his card in the machine. The transaction kicks off. The terminal then says, "Hey, cardholder, you can pay with either one of these applications that we found in the card, and which one would you like to pay with?" And Bob looks at the screen and he sees MasterCard and MasterCard. Now, that's extremely confusing for us. So, in order to resolve this issue, we now use something called a preferred name. Okay. So remember, we still in our same example, one physical card, two virtual cards, we're using a PIC extension, we know we've got a MasterCard credit and a MasterCard debit application on the card, right? What we now can do is throw in something called an application preferred name, okay, and that is in tag 9F12. This, for some strange reason, is an optional tag and is determined by the issuer. Okay. And it allows the issuer to give a more meaningful description, that may seem better than the application label, right? So something like a MasterCard debit or gold credit or whatever it is you want to call it. Application preferred name supersedes application label on terminal display. Now, what this means is during a transaction, the terminal will use the AIDs to quickly locate which sort of virtual cards are available for transacting. The next step it'll do is says, okay, I need to present this to the cardholder. Let me go and look firstly for application preferred name. Okay, so it'll always try to find a preferred name first. Only if it doesn't find, so if the card hasn't been personalized with a preferred name, will it then default to the application label. Okay, so let's have a look at our growing table. So we've got a card, we know it's got two AIDs, in our case would PIX extension separated into two. We know each AID has its own label, but in this case the labels are sort of meaningless because they're exactly the same. But the terminal will try to find an application preferred name first, and in our card's case, it can find one. It can find both preferred names. And so when Bob looks at the screen now, what he sees there is MasterCard Gold Credit or MasterCard Debit. So now to a human being, this becomes very easy to differentiate between, does he want to pay for his socks using his credit card, or, does he choose to rather purchase using his debit card? We're going to move on now to the discussion around application priority indicator, okay, and this still revolves around the AID. Okay, same example, one physical card. We know we've got two applications, two virtual cards on it. We know that they have PIX extensions to differentiate both. We know that for the purposes of presenting to a customer, we've personalized the application preferred name on the card, right? So what we now have to do is apply an application priority indicator, and this is depending on the specifications, EMV Co or MasterCard or Visa or Amex or Diners. It could either be optional or conditional depending on what the scheme requires, right? So it's got two parts in it, right? So the way we construct the application priority indicator is as part of the construction of it. There's in hex. If you translate to binary, what you'll find is that one of the bit sets actually also acts as an indicator to the terminal. Whether it'll force a customer to always select the application, or whether in the case where there's only one application available for transacting. So for example, let's say the terminal only supports the credit application and doesn't support the debit applications, in which case in byte 1 bit 8 we can then tell the terminal that if you only find a single application, then you don't need to force the cardholder to select it. You can allow the terminal to automatically select a single available application, right? So a bit more complicated, a bit more technical. I've put a reference here, EMV Code Book 1, page 138. For those of you who are interested, if you're not really interested, don't stress. It's a bit of heavy reading right off the bat. Sometimes the nerd in me gets the better of me. Okay. In human terms, the purpose of the application priority indicator, over and above allowing application to be auto-selected or forced user selection. It also determines the order in which multiple applications should be displayed on a terminal for selection by the cardholder. Okay, and let's look at the table before I expand on this. So what we've got here is a single physical card. We've got two applications. We know this is the MasterCard credit and we know this is the MasterCard debit, right? So the label says MasterCard, but we know it's MasterCard credit at the top because the preferred name says MasterCard Gold credit and the next one says MasterCard debit. What you'll see is that we've put an indicator, an application priority indicator for the first one as 01 and for the second one as 02. Now what this means is during every single transaction, and all the terminals that are processing transactions using this card, they will always look at the priority indicator, and when they display to the cardholder, Bob, which of these two cards would you like to use? Would you like to use your credit card or your debit card? They will always display the applications on the terminal for selection in this order. So regardless of which terminal is used, if the terminal supports both applications, Bob will always be asked to choose the credit card first. So basically the first row displayed on the terminal screen will be the credit application, and the second row will always be the debit application. Okay, so I think we're ready to move off AID and its associated tags, and so our next focus is going to be on application effective date. Application effective date has a hex tag of 5F25. Okay. And in theory, this is the date from which the application may be used. Okay, so what it means is the application may only be used if the transaction date is greater than or equal to the application effective date. Just note something, that simply by writing a date to this tag, on its own, it doesn't determine the behavior of the card, right? It doesn't do anything on its own. All it does is that it sets a peg in the ground, right? It sets a benchmark. It says, for the card, we have an effective date of, I'm just going to thumb like a value, 1st of February 2023, right? So in theory, what we're saying is that the card becomes effective from the 1st of February 2023. Okay. But on its own, this application effective date doesn't prevent the card from being used before. It doesn't prevent a transaction from being approved if used before. There is a later, there are action codes that we will be discussing later on, somewhere in the course of the next two videos. And what happens is those action codes will reference this application effective date, and those action codes will determine whether the rule says decline the transaction or send the transaction online for processing or approve the transaction, right? And later on, when we do, so we will discuss the action codes later on in under EMV parameters, under EMV issuing. But when we start doing the EMV acquiring sections later on, and we start walking through the transaction flow, we will discuss how this is actually referenced during a particular phase of the transaction called processing restrictions phase. Excuse me. So when we write this information to the card, okay, we store it in the format of year, month, day, right? And if year is between the values of 00 and 49, then we deem the century to be 20th. So we deem that the century to start would a 20, right? And if it's between 50 and 99, then the century is 90, right? It's probably redundant now. Obviously I'd done the training way back in the day, just in the early noughties, late 1990s, early noughties. So you actually shouldn't see this anymore. But basically, what it says that if you had a card starting with, for example, 120201, the fact that it had 1-2 meant that it was 2012, right? And if it had started with a 6-5, then we know it couldn't have been 2065. It actually meant 1965. Okay. Okay, so let's talk now about application expiry date, 5F24. Now, application expiry date works sort of very similar to application effective date. Okay, it's a date we write to the card, and the purpose of this is that in theory, if the card, if you attempt a transaction for this application after it's expired, after expiry date, it could be problematic, right? So what we're saying is we are establishing a use by date for this card, right? Similar to application effective date, application expiry date on its own doesn't do anything. We're just establishing what is the use by date, what is the last date this card may be used, right? However, during a transaction, this tag on its own won't affect the behavior of the transaction. All it does is that during the processing restrictions phase of a transaction, this expiry date will be referenced, and action code set up on the card, which we will discuss later on, will then make a ruling, based on how you've configured it, as to whether we should decline the transaction immediately or send it online or allow it to approve. Okay. The application expiry date, right? Tag 5F24 that we write on the chip. Remember, we're talking about this tag as it lives on the chip, right, within the application. It must correspond with the expiry date value that we store on the magstripe. It must also match the expiry date that we print or we emboss on the face of the card for single-app cards, as well as for the primary application on multi-app cards. Okay, and what we're trying to say is this: if you have a card that has a single card, and let's assume that it's a pure credit card, it doesn't have multiple applications, it only has a single credit application on it. Okay, so what we're saying is, whatever expiry date is reflected within the chip in the software application, okay, the exact same expiry date must live on the magstripe, and that is the expiry date that is also printed or embossed on the face of the card. Okay. In the case of multi-app cards, let's go back to the example that we've been using all along. Single card, we said we have two applications, a MasterCard credit, a MasterCard debit. We know we've got two AIDs, we've got PIX extensions to differentiate, we've got a preferred name that makes things, make it look nice. We had said that the primary application was credit card. We gave it the highest priority 1, and then the second one was MasterCard debit. So if you looked at the physical piece of plastic, what it should do is the face of the card would be embossed with the primary application's details. So in our example, because the credit card was the highest priority, it was priority 1, that is the primary application of this card, right? So that is the application that is top priority, and so the details of that application will be, must be displayed on the physical card itself. So what you'll find is that the expiry date for the credit application must be on the face of the card, and it must be on the magstripe. Okay, and this is because you could have a scenario where you've got multiple applications on the card. Would, for example, the credit card application have an expiry cycle of 5 years, and the debit application could have, of 3 years, or whatever weird scenarios could come up, right? So the point I'm trying to make is you could have differences in the activation dates and the termination dates of the two applications, and so the physical component must match what is personalized for the primary application. Okay, let's talk a bit now about PANs. Okay, so primary account number, or PAN as we say quickly, and the tag for this is 5A. So we've discussed PAN in the previous section, under I think both the introduction to EMV as well as EMV issuing, and so you guys should be familiar with the concept of PAN. And we say that the PAN can vary in length, usually between 14 to 19 digits long. Yeah, but we generally see the PAN is being set to 16 digits long. And that's very, very commonplace. So we store the PAN on the chip within the application as tag 5A, okay, and it must correspond with the PAN that's on the mag stripe, must be the same as the PAN on the mag stripe, and it must be the same PAN printed or embossed on the face of the card, okay. And remember how we spoke about the differences between multi-app and single app and primary applications in the previous slide. So the same applies here. If you've got a card that is a credit card only, it's a single app card, whatever's on the mag stripe, whatever's printed on the face of the card must be the same PAN number that's in tag 5A within the chip. If you've got a multi-app card, like the example we've been carrying through so far, then the same principle applies as previously discussed. So in the case of the credit card application, which is the primary application, the PAN for that credit card application written in the chip tag 5A will be the same that's printed on the face of the card, and will be the same that's personalized into the mag stripe. The secondary application, let's talk about the MasterCard debit application. We said it's priority 2, it's not the primary application. So that PAN number, that tag 5A, will only live within the chip, in the MasterCard debit application as tag 5A. Okay, most issuers will print that PAN as well somewhere on the back of the card. And that's generally for ease of use for e-commerce purposes. Okay, we're going to talk now a bit about PAN sequence number. Okay, so we're starting to get a bit more technical now as we delve deeper and deeper into the card. So the PAN sequence number, PSN, is tag 5F34. It's also called card sequence number, CSN. So if you see CSN or PSN, they mean the same thing, right? A PAN sequence number is used to differentiate between different cards with the same PAN value. It is passed up to the issuer host system during the online transactions. Okay. Just a point to note here. So a card sequence number or PAN sequence number is in my experience, is never personalized onto the physical plastic as well. So you won't see a PAN sequence number anywhere on the face or in the back of your chip card. This lives only within the chip. Okay? And it's not really used in a transaction, but it is passed up in a transaction. So that the host can differentiate between a sequence of cards that may have been issued to the same PAN number. Now, what it means is this. Let's assume that I've been issued a credit card, 5 years ago with a 5-year expiry, and my card is expiring at the end of January 2023. Okay. My bank issues me with another card, has a replacement with an expiry date 5 years in the future. So let's just say that it will be effective from the 1st of February 2023, and it will expire at the end of January 2028. Right. So what this means is that if I receive my replacement card on the 15th of January, right, it means I've got two cards in my possession. I've got my old card that expires on the 30th of Jan 2023, and I've got my new card that expires at the end of Jan 2028. But both cards will have exactly the same PAN number, right? And so sometimes you want to do, certain sort of analysis or processing to understand whether the transaction is coming up, from the older card or from the newer card. And yes, I suppose you could identify that by looking at the expiry date. But what you'll find is that in a lot of instances, where you've got EMV processing happening on the background, the card sequence number, the pen sequence number comes in very handy, especially where you're starting to track things like application transaction counters and stuff like that. So what this means, let's assume that the card I've got in my possession right now that expires at the end of the month was the very first card that this bank had issued to me. So, they would generally issue me the card with pen 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. Uh, and in the background on the chip itself, it would have a PSN of 1. When I receive my new card now, midway through Jan, and I know it's going to expire by 2028 only, if I look at the card and, if I look into the card, it's going to have exactly the same pen, 1, 2, 3, 4, 5, 6, 7, 8, 9, etc., etc., right? But on the chip, within the application, it will have a PSN value of 02. And so when a transaction is sent online, right, the message will actually indicate a PSN of 1 or 2, right? So the issuer host, let's assume that they're doing transaction verification to say, like, could this be a fraudulent transaction? Could somebody be manipulating data? We know that my previous card had a transaction count of 75, and all of a sudden we're seeing the same PAN number with a transaction count of 5. When those 70 odd records, just vanished. Hang, then the backend host can say, but okay, hang on. It will use pen plus pen sequence number to identify the difference between the old card and the new card. And so it knows that, okay, what we're seeing is that this fifth transaction that's come up is actually on the second card, not the first. So it won't set off any alarms in terms of any fraud checking or EMV validation happening in the background. Okay. All righty. Let's move on to application currency code. Application currency code is tag 9F42, and this is written as a 3-digit numeric code under the ISO 4217 standard. Okay, and it's written to the card as 2 bytes. Okay, you say 2 bytes, what you mean is 4 characters. So examples of this would be South African Rand, which is 710, and so we write it to the card as 0710. Okay, US dollar is 840, and we would write it to the card as 0840. And the same principle applies to euros. It's 978, and we would write it to the card as 0978. This is quite an important field, as it is used during transactions to identify, whether the transaction is an international transaction or a domestic transaction. And you'll recall in the last video in counters, where we spoke about certain counters only incrementing if it's an international transaction or only incrementing if it's a domestic transaction. And that assessment and verification of whether it is international or domestic is actually done by actually checking the currency code, right? So if the card currency code is not equal to the transaction currency code on the terminal, then the transaction is deemed to be an international transaction. Okay. Let's move on to application currency exponent 9F44. The currency exponent indicates the number of decimal places that we must cater for during a transaction. Okay. So it represents a number of decimal places between the smallest defined currency unit and a whole currency unit. Okay. So for most currencies, this number is 2. And to further elaborate, as an example, 1 South African Rand is made up of 100 South African cents, right? So you could have a maximum of 99 cents, before it becomes 1 whole rand. Okay, and so because the decimal point is not sent up on the transaction message, it's important to understand what the currency exponent is, so that you can actually allocate in this example the last 2 characters to be cents and the rest to be South African rands, right? Now, you may be wondering, how important is this? Surely everyone uses sort of this system of, one unit made up of 100 smaller units, but that actually isn't the case, right? So, and some examples that I've pulled up off the internet are, the Japanese yen doesn't have a smaller subunit, nor does the Icelandic krona. Okay, whereas the Iraqi dinar and the Omani rial both have a currency exponent of 3, which means they've got 1,000 of the subunits that makes up one unit. Okay. Okay. Now we're talking about issuer country code. Okay. Tag 5F28. The issuer country code is a 3-digit numeric code that conforms to the ISO 3166 standard. Okay. It's written to the card as 2 bytes, right? So very similar to the issuer currency code that we spoke about earlier. Examples of this are South African 710, we write it to the card as 0710. United States of America is 840, we write it as 0840. Germany is 276, we write it as 0276. Okay. So it usually looks the same as the issuer currency code defined under ISO 4217. And I think if you guys remember, and you're welcome to sort of scroll back, and if you look at the issuer currency code values, you'll sort of see that South African Rand and South Africa are about 710, and US dollar and the United States of America about 840, and etc. So generally they are the same, but there are exceptions, right? So, and especially when you look at regional entities like the European Union. So we say that Germany has an issuer country code of 276, but the currency is a euro. And so in this case, the currency code is not equal to the country code. The currency code is actually 978. Okay, so let's move on now to language preference. Language preference is a 2-digit alpha code that conforms to the ISO 639 standards. And examples of this are, so for English we'd use EN, for Arabic AR, for Germany DE, etc. If you're interested in what the other ones are, please have a look at the ISO 639 standard. Generally, a card can support up to 4 language preferences. And what this is for is that it allows for customers to interact with a terminal in their preferred language, where the terminal supports multiple languages. Okay, so if you have a terminal that supports English, French, Arabic, and something else, it allows you as a customer to be able to interact with the terminal in the language of your choice. Okay, obviously this is dependent on the terminal itself being able to support multiple languages. Okay. Okay, so now we're talking a little bit about, so now we're getting a bit more technical, and we're talking about DOLs, data object lists. So the first DOL we're going to speak about is something called the Processing Options Data Object List, or PDOL. Okay, and this is tag 9F38. The PDOL is the list of terminal data objects, right? This is important. Of terminal data objects that the chip needs during transaction processing. So what we're saying is during a transaction, right, the terminal will do some risk management, the card will do some risk management, but as part of the risk management that needs to happen, the card needs some pieces of key information from the terminal that it needs to factor into its risk evaluation. Okay. And so in order for it to get this information from the terminal, what it does is it uses something called a PDOL to request it from the terminal. Okay. PDOL is optional and may not be found on all cards. Okay. So basically what happens is, during the transactions, during the get processing options phase of the transaction, the card will send the shopping list right to the terminal and say, I need the following pieces of information, and it will give it a list of tags that it requires in a particular order. And what happens is that the terminal will will look at the shopping list and return the information that the card has asked for in the order that it was asked for, right? Now, some of the things that the card could ask for from the terminal would be things like terminal type, and we've discussed this. So terminal, what type of terminal are you? Okay, are you a terminal type 22? Excellent. Terminal capabilities. You know, what can you do? Can you process a chip transaction? Can you do offline data authentication, etc., etc.? Merchant category code. What type of merchant? What kind of a transaction is this? A purchase? Is it a purchase or cashback? A terminal country code. So in which country is a terminal issued? Is it 0710? So is it a South African terminal? And transaction category code, right? And so, as explained, the terminal will receive this shopping list or this request for data, and it will respond back to the card to say, uh, okay, card, this is the stuff you asked for. I've filled out your order, and here's the information. Here you go, and it passes it back. It passes it back to the card for it to use during its processing. Okay. So this sort of covers what PDOL does at a very high level. So I think that let's go on now and talk about more data object lists. So we're going to talk a bit about CDOL 1 and CDOL 2. Okay. At this point, let me say that if the conversation has taken a dark turn and it's gotten too technical too quickly, and if maybe you are struggling to keep up, please don't stress, don't worry about it. Uh, try to remember what you can, try to understand what you can. When we get into the EMV acquiring, once we actually do the step-by-step blow of and walk through a transaction, I'm not guaranteeing that you'll understand it 100%, but I can guarantee that things will make a lot more sense. So I think the objective is during this EMV issuing section is just to make you familiar with the various tags, and what the functions, and in some instances how they are used, but the actual understanding will come later on when we start doing the transaction flow, and we start referring back to all of these concepts that we discussed in these videos. So please, I ask you, just bear with me. If you're not able to remember everything, don't stress about it. Hopefully, as we progress, we will sort of will get refreshes as we talk through the content. Okay. So whilst we're on data object lists, so there are two other data object lists that we should mention. Uh, CDOL 1, which is Card Risk Management Data Object List 1, and CDOL 2, which is Card Risk Management Data Object List 2. Okay, tag 8C and tag 8D. CDOL 1, CDOL 2 are used during the first and second gen AC phases of a transaction, respectively. We will be speaking about first gen AC and second gen AC later on during the transaction flow. So don't stress about it. Just understand that as part of this transaction phases, uh, the card will request information from the terminal, and it will request it in the form of this shopping list, right? So during first gen AC, it will send a CDOL 1 request, and during second gen AC, it will send a CDOL 2 request. Okay. As I said, we will discuss it in greater detail, in greater depth in a later section. All right. Interesting for you to know that some of the information that the card will ask for, during first gen AC, CDOL 1, or second gen AC, CDOL 2, things that it will ask for is unpredictable number from the terminal. This is something that the terminal generates. What is the transaction amount? What is the transaction currency code? Important here because we're going to use it to figure out if it's an international or domestic transaction. terminal type, terminal country code, terminal verification results. We're going to speak a bit about this later on. Very important part of EMV, data authentication code and transaction data information. You'll see that serial 2 is very similar. There are some additional things that it asks for, like issue authentication data, authorization response code, and things like that, which only really exist in second gen AC. Okay, you don't need to memorize the list of things. They are easily you can look them up on the internet, and you can pick them up in the technical specification from EMV Co and the card schemes. All right. So let's move on now to something called PIN try limit, PTL, tag C6. Okay, now you'll recall that in the counter section, we spoke about there are two ways in which counters work. You've got the one where a counter is used on its own, and then you've got the second one where the counter was used in conjunction with a pin try limit. Okay, so that pin try limit that we sort of alluded to as part of the counter discussion, we're actually just including that PTL pin try limit is a tag. It lives on the card, and it's tag C6. Okay. And remember, so during a transaction, when customers input their PIN, when there's incorrect PIN entry, the card keeps a record of those incorrect PIN entries through the counters, and it simply just compares those counters to this limit that we set up on the card during personalization. Okay. So remember, as we said before, not all cards use a PTL. If a limit is used, then the counter is set to 0 at personalization. And when we reach a stage where your pin try counter is equal to your pin try limit, then we say that at that point in time, we're in a state where the pin is blocked, or we say that the pin try exceeded or the PTC has been exceeded, right? If no limit is used, right? Remember we said that the counter will be set to a pin try limit. For example, if business says, look, we want to allow customers to only have 3 attempts at the PIN. So when we personalize the card, because there's no PIN try limit to say, let's set a PIN try limit of 3, what we actually do is we set the counter value on issuance to 3. So that's its default state. And every time a customer puts it in incorrectly, it will decrement from 3 to 2 to 1, etc. And we say that the pin try, we say pin try exceeded or pin blocked when, please excuse me, this is incorrect, when your pin try counter equals 0. Okay, this is the error, so my apologies for that. So as an example, we said MChip Advance, which is a masking applications, uses the PTL as part of its standard. Okay. Later on, I think there's a section for EMV for EMV lifecycle management. We will discuss pins in a lot greater detail. We'll go into how pins are set up and how pins are managed, etc. So if pins, if the subject of pins is something interesting, just hang tight. We will be talking a lot more about pins in a later section, in a later video. Okay, but as it stands right now, I think this video has been quite long, so I think this is a logical point for us to break. So I will be stopping the video here, and when we kick off with video 9, we'll basically just kick off from this slide and then progress, into the second third of the slide set. Okay, thank you so much for spending the time with me, and I look forward to seeing you guys again in my next video. Cheers.